This is Dr. Manjunath Chennapgood from Anveshana Academy, Bangalore, India. So today I will start the new subject Applied Thermodynamics for Mechanical Engineering students. The first unit is gas power cycle. Okay, so today I will start first unit that is gas power cycle. Dear students, before going to gas power cycle, so why these gas power cycles are required? Is there really necessity of this gas power cycle? Yes, the gas power cycles are very much required for our day-to-day life. In the previous days, the most of the scientists they have sacrificed their life towards the invention of different engines, either it is gas engines, steam engines, or petroleum operated engines. So now these all are the products of gas power cycles. So now what actually this gas power cycles tells us? The gas power cycles is, so initially in the olden days the gas they observed the hot gas, that hot gas have an explosive forces. The scientists they had thought this hot gas have an explosive force. That explosive force can be used to get the mechanical energy. If once we got the mechanical energy, from that mechanical energy we can do different kinds of work. So that means this tells about law of conservation of energy. In nature we can see, dear students, different kinds of energies are already available in nature, but sometimes though available energy which are there in nature we can't use directly sometimes. So what we have to do, we have to convert the one kind of energy into another kind of energy, and as per our requirement then we can use that energy. Like we can take an example, wind energy. So wind energy is already available in the nature, but this wind energy we can't use to run the machines. So or to run the machines, so we require electrical energy. This wind energy directly can't use to run the engine. So scientists what they thought, this wind energy can be converted into electrical energy by using a machine. That machine you can call it as wind turbine or windmill. Similarly you can take any biomass or fuels. You can take that fuels itself, they having chemical energy in themselves. Like you can take a petrol, you can take a diesel, you can take a biomass, you can take a coal. They have chemical energy, but that chemical energy we can't use sometimes, but that chemical energy can be converted into electrical energy by burning it. Okay, when we are going to burn the fuels like biomass, we can take coal, you can take, they are going to produce the hot gas. They are going to produce the hot gases. That hot gas having an explosive force. With the help of that explosive force we can run the turbines. Once the turbines started to run, the turbine can generate the mechanical energy. From that mechanical energy we can move from one place to another place with the help of a machine, that is engine. So like that, what we can do, we can use the machines to convert one kind of energy to another kind of energy. That is something what law of conservation of energy. So in the same way the scientists they have done a lot of research to convert these hot gases into mechanical energy. Yeah. So therefore the usage of this hot gas become rich in history, and it is rooted many things for the early inventors and scientists to utilize these hot gases and to get a mechanical energy. So dear students, you can see here now how they have thought actually. So already in nature we can get different kinds of energy. So they thought to convert that energy, you can say fuel energy, the nature whatever you can take, biomass or coal or petrol or whatever you can take. They thought to convert that fuel into energy as per the requirement. They what they have done? They have burned. When they burn, they produce the hot gas. That hot gas itself have an energy. So with the help of that energy we can get mechanical energy with the help of a machine. So that hot gas they have supplied to a machine or a component or element. That machine generated the mechanical energy. So that hot gas they use to engine or machines or turbines that generated the mechanical energy. With the help of that mechanical energy they started to produce the electrical energy. Once the electrical energy is generated, that electrical energy they have started to use for the different applications in different sectors. So this is how the gas power cycles play a very important role in our day-to-day life. Then how these hot gases, dear students, you can take to understand better. I will try to take one example and I will tell you what actually the hot gases. So these hot gases play a very important role, very important role. How it is that we can see here now. Assume that, dear students, you are taking in a water into a container. So when you are going to heat that water with the help of a heater, that water will slowly, it will it will get heat up. Then once it's get heated up, then after reaching the saturation temperature, that is 100 degrees Celsius, slowly that water is going to convert it into steam or a gas. When it becomes a gas, hot gas or hot steam, it is having a force, explosive force. That explosive force we can pass on to the engine or turbine, so we can get the mechanical energy. Then that mechanical energy can be converted into electrical energy with the help of an electrical generator. So like this they thought and they started to utilize the hot gases. Fine. Then how it is then, dear students, you can see one application I have taken. Assume that you are getting a hot gas from the boiler. That hot gas we are going to pass on to the turbine. Once the hot gas is explode or when it is hits on the turbine, it will start to rotate the turbine will start to rotate. Once the turbine is start to rotate, that means turbine is already connected to electrical generator. When the turbine start to rotate, the turbine is connected to electrical generator by means of a shaft actually. Once the turbine start to rotate, shaft is going to rotate. If the shaft is rotating, one kind of energy is going to generate there. That energy we can call it as a mechanical energy. Dear students, initially when we are going to burn the fuel, right, it is in the chemical form, chemical energy. When you burn, that is converted into hot gas. That hot gas itself having an energy, that heat energy we can call. When you are going to force that, when you are going to hit that hot gas onto the turbine start to rotate, I mean shaft is start to rotate. When the shaft is started to rotate, it's going to produce energy. That energy you can call it as a mechanical energy. Then that later that mechanical energy is converted into electrical energy with the help of an electrical generator. Once the work is done, the whatever the hot gases is there in the gas turbine, it will come out and it will enters into the condenser. There again it is going to condenses and it will be taken out. Dear students, some key terms are written here where T represents torque and W represents work done, N represents speed of the shaft, where H1 and H2 are the enthalpy of the hot gas inlet as well as the hot outlet. This is how the hot gas play a very important role to convert chemical energy into mechanical energy into electrical energy. In this way, they started to do research and investigations on the hot gases operated engines. Later, they called them as a gas power cycles. Okay, fine. Okay, so then what are the importance of this gas power cycles? So you can see, dear students, importance of gas power cycles. So these gas power cycles are used in the high power to weight ratio engines, we can say, where the sector is aviation we can take, And we can take a portable power generation. We can take a small electrical power generating system unit, generator you can call. Okay, there we started to use this gas power cycles, because these engines, we can take a aviation engines, you can take a portable power generation engines, these are designed based upon the gas power cycle. When it comes to gas power cycle, there are different types of gas power cycles are there that I will discuss in detail in upcoming classes. Now we are discussing about only gas power cycles. Okay, importance. Now gas power cycles can be used to convert the energy. So in energy conversion we are using the gas power cycles. Where it is, we can see here now, where, as I told, petrol and diesel engine, you can say petrol and diesel engine. Petrol itself, it is having a chemical energy that can be converted into mechanical energy with the help of a machine. That machine is, we can call diesel or petrol engine. That petrol or diesel engine is designed based upon the gas power cycles. Again, there will be two cycles will come. One is Otto cycle and diesel cycle. Those are nothing but what? Gas power cycles. Okay, that I will discuss in detail next. Okay, so with help of this gas power cycle, we can design diesel or petrol engine. With help of that petrol engine or diesel engine, we can convert fuel energy or chemical energy of fuel into mechanical energy. Okay, later we can see, dear students, later we can run the pumps or a drive with help of that mechanical energy. Hence we can run the pump or we can run the compressors. So based upon the petrol or diesel engine, with help of petrol or diesel engine, we can run the pumps or compressor. Again, that petrol and diesel engines are designed with the help of the gas power cycles. The fine. Now, so based with the help of this gas power cycles, we can design aircraft applications like jet engines, modern aircrafts. There also we are using the fundamentals or applications of gas power cycles. That fine. Now in power generation, we are using gas power cycles. You can take Rankine turbine, you can take Carnot cycle, you can take. Okay, so like that, different types of gas turbines will come, power generation systems will come. Those are working based on the principle of gas power cycle. With help of that gas power cycles, we can run the gas turbines. With help of that gas turbines, we can generate the electricity, dear students. And with help of this gas power cycles, we can do fast startup. So whenever peak demand is there, right? So suppose if you require electricity more nowadays, that what we can do, with help of this gas power cycles, you can burn the more fuel like coal or biomass energy. Immediately you can generate the electricity as per your requirement. That too immediately. That means what? They will produce electricity immediately. These all are the applications of the gas power cycles. So this is how it play a very important role. So sometimes combined cycle efficiency also we are using, we are going to develop with help of a gas power cycles. So like that, steam turbines or thermal efficiency we can improve with help of this gas power cycles. And also to we can, with help of this gas power cycles, we can determine the efficiency of the engines as well as the gas turbines, so we can get the thermal efficiency. This is about gas power cycles. Dear students, here I request you, please do subscribe my channel, like and comment. Your subscription, like and comment will help me a lot to do more and more video. Thank you.